Good dear students, welcome to physics class of P1. We have been discussing about the chapter laws of motion. In the introduction part, we discussed about the Newton's laws of motion and what is inertia. So in the Newton's first law of motion, we have discussed about what is Newton's first law of motion and about the concept of inertia we have discussed. And the second law, F is equal to ma, the rate of change of momentum is directly proportional to the applied force, right? And it takes place in the direction of the applied force. And third law we have discussed, that is, to every action there is an equal and opposite reaction, or action and reaction acts equal in magnitude but opposite in direction. After that, the law of conservation of momentum. We have given the statement and we have proved it, right? The total initial momentum is equal to final momentum, that is we have proved. Now in today's class, let us discuss here about the next point, that is about the equilibrium of a particle. When you say that an object is in the equilibrium position, right, that we have to discuss here with the condition. With the condition, we have to discuss here about the equilibrium of a particle. A particle or an object, right, it is said to be in the state of equilibrium under the action of several forces. It is said to be in the state of equilibrium if the vector sum of all the forces acting on it is equal to 0. ಒಂದು ವಸ್ತು ನಿಶ್ಚಲ ಸ್ಥಿತಿಯೊಳಗೆ ರೆಸ್ಟ್ ಒಳಗೆ ಅಥವಾ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್ ಒಳಗೆ, ಅವಾಗ ನಾವೇನು ಹೇಳ್ತೀವಿ, ದಟ್ ಬಾಡಿ ಇಸ್ ಇನ್ ದ ಸ್ಟೇಟ್ ಆಫ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ. ರೆಸ್ಟ್ ಒಳಗೆ ಐತಿ ಅಂದರೆ ಅದರ ಮೇಲೆ ಯಾವುದೂ ಫೋರ್ಸ್ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತಿಲ್ಲ, ಅಥವಾ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್ ಒಳಗಡೆ ಅದ್ರ ಮೇಲೆ ಕೂಡ ಯಾವುದೂ ಫೋರ್ಸ್ ಆ್ಯಕ್ಟ್ ಆಗ್ತಾ ಇಲ್ಲ. ದಟ್ ಮೀನ್ಸ್ ವಾಟ್ ಹಿಯರ್, ಫಾರ್ ಯೂನಿಫಾರ್ಮ್ ಲೀನಿಯರ್ ಮೋಷನ್ and when the object is at rest, that is the condition of what the equilibrium of a particle. A particle is under the action of forces is said to be in the state of equilibrium if the vector sum of all the forces acting on it is equal to 0. For example, condition for the equilibrium of two forces. So ಒಂದು ವಸ್ತು ರೆಸ್ಟ್ ಒಳಗಂದ್ರೆ ಅದ್ರಾಗ n number of forces act ಆಗ್ತಾ ಇದಾವೆ, ಬಟ್ ಎಲ್ಲ ಫೋರ್ಸು ಕೂಡಿ ಏನಾಗಬೇಕ್ರಿ, ನೆಟ್ ಫೋರ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಆಗಬೇಕು. ಅವಾಗ ಏನು ಹೇಳ್ತೀವಿ ನಾವು, ಕಂಡೀಷನ್ ಆಫ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಕೊಡ್ತೀವಿ. ದಟ್ ಮೀನ್ಸ್ ವಾಟ್ ಇಸ್ ಸಮೇಷನ್ ಆಫ್ ಎಫ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಫ್ರಮ್ ಐ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 to n. ನಂಬರ್ ಆಫ್ ಫೋರ್ಸಸ್ ಎಷ್ಟು ಆಕ್ಟ್ ಆಗ್ತಿದಾವೆ ಅದ್ರ ಮೇಲೆ, ರೈಟ್? ಅವೆಲ್ಲ ಫೋರ್ಸಸ್ ಸಮ್ ತಗೊಂಡು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ದಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 0 ಅಂತ ಬರಬೇಕು. ದಟ್ ಮೀನ್ಸ್ ಫಾರ್ ಕಂಡೀಷನ್ ಆಫ್ equilibrium of two particles, the object ಅಲ್ಲಿ one force ಈ direction ಒಳಗೆ act ಆಗ್ತಾ ಇದೆ, that is the force F1 acting in this direction and the force F2 is acting in this direction. Here the object O is, right? Now these two forces F1 and F2 are acting on a particle or the object. Then we say that the object is in the equilibrium state. ಇದು ಯಾವಾಗ equilibrium state ಒಳಗೆ ಇರುತ್ತೆ? That means what? F1 and F2 are equal in magnitude but opposite in direction, right? One force ಈ direction ಒಳಗೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, ಮತ್ತೊಂದು ಫೋರ್ಸ್ ಈ direction ಒಳಗೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, ಬಟ್ ಎರಡು ಈಕ್ವಲ್ ಅಲ್ಲ, ರೈಟ್? ಈಕ್ವಲ್ ಅದಾವ ಬಟ್ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ. ಸಪೋಸ್ ಎರಡು ಫೋರ್ಸ್ ಒಂದೇ ಕಡೆ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಆಕ್ಟ್ ಆಗತ್ತಿದ್ದು ಅಂದ್ರೆ ಇದು ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಸ್ಟೇಟ್ ಒಳಗೆ ಅದು ಮೂವ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, ರೈಟ್? F1 is equal to F2 but both are in opposite direction. ಸೊ ಇಲ್ಲೊಂದು ಆಬ್ಜೆಕ್ಟ್ ಅದ, ಒಬ್ರು ಈ ಕಡೆ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಮಾಡ್ತಾರೆ, ಇನ್ನೊಬ್ರು ಆ ಕಡೆಯಿಂದ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಮಾಡ್ತಾರೆ, ರೈಟ್? ಅಪ್ಲೈ ಮಾಡಿ. ಸೊ ಇದು ರೆಸ್ಟ್ ಒಳಗೆ ಉಳಿದೈತ್ರಿ. ಯಾವಾಗ್ರಿ ಎರಡು ಫೋರ್ಸ್ ಈಕ್ವಲ್ ಆಗಬೇಕು ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ, ಅಥವಾ ಒಂದ ಕಡೆ ಫೋರ್ಸ್ ಆಗಿದ್ರೆ ಯಾವ ಡೈರೆಕ್ಷನ್ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಇರ್ತೈತ್ರಿ ಆ ಡೈರೆಕ್ಷನ್. ಸಪೋಸ್ ಇಫ್ F1 is not equal to F2, ಎರಡು ಈಕ್ವಲ್ ಇಲ್ರಿ, ಅವಾಗ ಏನಾಗ್ತೈತ್ರಿ, ಯಾವ ಡೈರೆಕ್ಷನ್ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಇದೆ ಆ ಡೈರೆಕ್ಷನ್ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತೈತಿ, ರೈಟ್? ಸಪೋಸ್ ಇಫ್ F2 is greater than F1, ಅವಾಗ ಏನಾಗ್ತೈತಿ, ಇದು ಆಬ್ಜೆಕ್ಟ್ ಈ ಕಡೆ ಮೂವ್ ಆಗ್ತದೆ. ಸೊ ಸಿಂಪಲ್ and easy to understand the condition of equilibrium of a particle, right? A particle under the action of forces is in the state of equilibrium if the vector sum of all the forces acting on it is equal to 0 ಅಂತ ಹೇಳ್ತೀವಿ. That means what? F1 plus F2 is equal to 0. The ಮೇಲೆ ಎರಡು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ಬೇಕಾದ್ರೆ ಈಗ ಅವ್ನು ಎರಡನ್ನೂ ಕೂಡಿಸಿದ್ದು ವೆಕ್ಟರ್ ಸಮ್ ತಗೊಂಡ್ವಿ ಅಂತಂದ್ರೆ ದಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 0 ಬರಬೇಕು. ಅವಾಗ ಏನಾಗ್ತೈತ್ರಿ ದಟ್ we can say that what here the object is in the state of equilibrium. Now let us take the condition for three forces. Three forces consider ಮಾಡಿದಾಗ ಏನಾಗ್ತದೆ, right? For example, here is the object, one force acting in this direction, right, and another force acting in this direction, right, and third force is acting in this direction. So this is F1 and this is F2 and this is F3. The three forces are acting on the object here, right? What is the resultant of these two? ಇವೆರಡು ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಆಕ್ಟ್ ಆಗತಾವ್ರಿ. ಇವು ಎರಡರದ್ದು ರಿಸಲ್ಟೆಂಟ್ ಒಂದು ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಬರುತ್ತೆ. So this is the resultant of what? F1 and F2. This is what? F1 plus F2, the resultant of it. So this can be determined here by using the parallelogram law of vector addition, right? We can determine the resultant value by using the parallelogram law of vector addition, right? So now here the two forces F1 plus F2, that is the resultant of F1 and F2. F1 and F2 the resultant e direction ಒಳಗೆ ಬರ್ತೈತ್ರಿ, right? F3 e direction ಒಳಗೆ. So when we say that this object is in the state of equilibrium, the number of or the vector sum of all the forces acting on it is equal to 0. F1 plus F2 e direction ಒಳಗೆ ಅದರಿ, F3 opposite direction. So when this body is in the state of equilibrium, that is F3 is equal to minus F1 plus opposite direction ಒಳಗೆ ಆಕ್ಟ್ ಆಗಬೇಕ್ರಿ. ಮತ್ತು ಅವರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ಸ್ ಏನಾಗಿರಬೇಕು, ಈಕ್ವಲ್ ಆಗಿರಬೇಕು. ಆ ಕೇಸ್ ಒಳಗೆ ಏನಾಗ್ತದೆ, ದ ಬಾಡಿ is said to be under the action of the equilibrium state. So then what we can write? Therefore F1 plus F2 plus F3 is equal to 0, right? A particle under the action of forces is in the state of equilibrium if the vector sum of all the forces acting on it is equal to 0. All vector sum of the forces is equal to 0 bantandre avage ಏನು ಹೇಳ್ತೇವೆ ನಾವು, that is the body is said to be under the state of what? The equilibrium state, right? Easy to understand. ಯಾವುದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ತಗೊಳ್ರಿ, ನೀವು ಒಂದು ವಸ್ತು ತಗೊಳ್ರಿ, ಆಮೇಲೆ ನಂಬರ್ ಆಫ್ ಫೋರ್ಸಸ್ ಆಕ್ಟ್ ಆಗ್ತಿರ್ತಾವ, ಅದು ರೆಸ್ಟ್ ಒಳಗೆ ಐತಂದ್ರೆ ಸಮ್ ಆಫ್ ದ ಫೋರ್ಸಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಅದ. ಮೂವ್ಮೆಂಟ್ ಆಗಕತ್ತದ ಅಂದ್ರೆ ಸಮ್ ಆಫ್ ದ ಫೋರ್ಸಸ್ ಇಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 0 ಅಂತ. So it's easy and simple to understand about what the condition for what the equilibrium of a particle. For n number of forces, what we can write here? ಇಲ್ಲಿ 3 forces consider ಮಾಡಿ. So n number of forces ಇಲ್ಲಿ ಬಂದ್ರೆ ಏನಾಗ್ತದೆ, F1 plus F2 plus F3 and so on up to what we can write here, that is Fn is equal to 0. So this is the condition for what the equilibrium. A particle under the action of forces is in the state of equilibrium if the vector sum of all the forces acting on it is equal to 0. This is known as about the condition for equilibrium of a particle. Now the next point we have to discuss here is about the common forces in mechanics. So what are the common forces in mechanics we have to discuss. Then after that we have to discuss about the friction, that is the contact force, contact and non-contact forces, right? Contact force andre endre non contact force antandre. So example for the contact force is what? The friction, right? ಎರಡು ಬಾಡಿ ಅಪೋಸಿಟ್, ಒಂದು ಬಾಡಿ ಮೇಲೆ ಎರಡು ಬಾಡಿ ಕಾಂಟ್ಯಾಕ್ಟ್ ಒಳಗೆ ಇದ್ದಾಗ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿರ್ತದೆ. ಫ್ರಿಕ್ಷನ್ ಅಂದ್ರೆ ಏನ್ರಿ, when there is an opposite motion or the relative motion between the two objects in the opposite direction, ಅವಾಗ ಫ್ರಿಕ್ಷನ್ ಇರ್ತದೆ, right? That is called as the contact force. Non contact force ಅಂದ್ರೆ ಏನ್ರಿ, what is mean by non contact force ಅಂದ್ರೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಸ್ತುಗಳು ಕಾಂಟ್ಯಾಕ್ಟ್ ಆಗೋದಿಲ್ಲ ಬಟ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿರ್ತದೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ the bar magnet, if you can consider the example, right? So bar magnet you consider the example ana tagondhaga enaagtide, right? S and N poles we have, right? The two poles, the two S poles repel, right? And the S and N poles attract. So you can see here the bar magnets. So these are the bar magnets here. So we have the N pole and S pole, and N pole and S pole. So two S poles, right? There is a repulsive force. ಇಲ್ಲಿ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. but in this is not a contact force, this is non-contact force, right? But they are in S and N poles attract each other, force act ಆಗತೈತ್ರಿ, ಅವೆರಡು ಕಾಂಟ್ಯಾಕ್ಟ್ ಆಗಲಿಲ್ಲ ಬಟ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. This type of forces are called as what here, the non-contact forces, right? S and S pole repel. So ಎರಡು ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಒಳಗೆ ಇದಾವೆ, ಅವೆರಡು ತರ ಡಿಸ್ಟೆನ್ಸ್ ಇದೆ ಇಲ್ಲಿ, ಬಟ್ ಅಟ್ರಾಕ್ಷನ್ ಆ್ಯಂಡ್ ರಿಪಲ್ಷನ್ ಐತಿ. ಅದಕ್ಕೆ ನಾವು ಇಂಥ ಫೋರ್ಸಸ್ಗೆ ಏನಂತ ಕರಿತೀವಿ, ದೀಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್, ದಿ non-contact forces. Now let us discuss here some important common forces in mechanics. The first one is about the weight. What is weight? You all know that. It is the gravitational force exerted on a body near to the surface of the earth. That is called as the weight of the body. Weight is nothing but what? The gravitational force acting on an object near the surface of the earth. Near the surface of the earth is called as what? The weight of the body, right? It is defined as what? The gravitational force exerted or the acting on an object near the surface of the earth, that is called as the weight of the body, and is equal to what? M into G, where G is what? The acceleration due to gravity. So for example, an object of body of mass m, right, which is hold at the rigid support. Now what is the gravitational force acting on it? Is that is W is equal to M into G. For example, here we have the body, right? What is the gravitational force acting on it? That is called as the weight of the body. So we have the object here, which is tied to a string with the rigid support we have here. Now this object is having the mass M. Then what is the gravitational force acting on the object, which acts in which direction? Which acts in downward direction. Gravitational force ಯಾವ direction will act ಆಗ್ತದೆ? That is weight W is equal to M into G, which acts in the downward direction, M into G. Now this is one of the force that is in mechanics, that is weight, the gravitational force acting on the object near the surface of the earth. Why we call it as the gravitational force, right? Now the acceleration due to gravity is acting on it. Now the second force, that is about the tension, right? So this object is holded here, right, under the tension. When this tension acts in what? The upward direction, right? What is meant by the tension here? The force exerted by the string is called as what here? The tension. The force exerted by the string, the force exerted by the string is called tension, right? The force exerted by the string is called as what here? The tension. It is denoted by the symbol capital letter T, and it acts in a direction away from the body. The tension acts on the body in a direction away from the body, right? And here this tension acts in upward direction, right? The tension ಯಾವ direction ಒಳಗೆ act ಆಗ್ತಿದ್ರೆ string ಮೇಲೆ, that is in the upward direction, right? So you can see the tension acts in the string in the upward direction, and weight on the body acts in the downward direction. So this is called as what here? The tension. Now when under the equilibrium state, what happens here? This tension is equal to weight of the body. Equilibrium state ಒಳಗೆ ಏನಾಗುತ್ತೈತ್ರಿ? Both are equal and opposite ಇರ್ತಾವೆ. But ಇಲ್ಲಾಂದ್ರೆ ಏನಾಗ್ತೈತ್ರಿ? If the weight of the body is more than the tension in the string, then the string will break here, right? So these two are the forces here. One is weight of the body, another one is tension. Now third one is here about the spring force. What is meant by spring force? What is meant by spring force? A compressed or stretched string develops a force to retain its original position, that is called as what here, the spring force. So now we have compression and stretching and compression. For example, here we have the spring here. Now spring when a weight is applied on it, right? When a weight is applied on it, there is a compression, right? Weight apply this spring become compressed, this spring becomes stretched, and now when I leave it again compressed it is, right? This is stretching and this is compressing, right? So the force developed in the spring, when there is a stretching and compression of the string takes place. ಈ ಸ್ಪ್ರಿಂಗ್ ನಾವು ಯಾವಾಗ ಸ್ಟ್ರೆಚ್ ಮಾಡ್ತೀವಿ ಅಥವಾ ಕಾಂಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ ಅವಾಗ ಆ ಸ್ಪ್ರಿಂಗ್ ಒಳಗೆ ಏನು ಫೋರ್ಸ್ ಡೆವಲಪ್ ಆಗ್ತೈತಿ ಆ ಫೋರ್ಸ್ ಏನಂತ ಕರಿತೀವಿ ನಾವು ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ ಅಂತ. ಆ ಡೆವಲಪ್ ಆಗಿದ್ದಂಥ ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ ಏನು ಮಾಡ್ತಿರ್ತಂದ್ರೆ it will make that force is directly proportional to the displacement and opposite to the direction of displacement, right? In spring, right, when I apply the weight to this spring it becomes stretch right? Stretch again, there is a displacement. In initial position there is displacement, there is a displacement of term x. So ignore in initial position right, it stretch ಮಾಡಿದಾಗ ಏನಾದ್ರೆ ಈ position ಇದೆ. So displacement ಎಷ್ಟಾಯ್ತದೆ, this is the displacement type, right? So then that spring force is directly proportional to displacement, right? ನೀವು ಎಷ್ಟು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಜಾಸ್ತಿ ಕೊಡ್ತೀರಿ ಅಷ್ಟು ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ ಡೆವಲಪ್ಮೆಂಟ್ ಜಾಸ್ತಿ ಆಗ್ತೈತೆ, ರೈಟ್? ನಾವು ಎಷ್ಟು ಅದನ್ನು ಜಾಸ್ತಿ ಸ್ಟ್ರೆಚ್ ಮಾಡ್ತೀವಿ ಅಷ್ಟು ಜಾಸ್ತಿ ಏನಾಗ್ತೈತೆ ರೀ ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸನ್ನು ಡೆವಲಪ್ ಆಗ್ತೈತೆ. ಬಟ್ ದಟ್ ಈಸ್ ಇನ್ ದಿ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್, ರೈಟ್? ನಾವು ಈ ಡೈರೆಕ್ಷನ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ ಅಂದರೆ ಈ ಡೈರೆಕ್ಷನ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಯಿತು. ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಇರ್ತೈತೆ ರೀ? ದಟ್ ಈಸ್ ಇನ್ ದಿ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್. ಅವಾಗ ಕಾಂಪ್ರೆಸ್ ಮಾಡಿದಾಗ ಏನಾಗ್ತೈತೆ ರೀ ಮತ್ತೆ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ ಡೆವಲಪ್ಮೆಂಟ್. ನೀವು ಕಾಂಪ್ರೆಸ್ ಮಾಡಿದಾಗ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ, ಸ್ಟ್ರೆಚ್ ಮಾಡಿದಾಗ ಕೂಡ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ ಡೆವಲಪ್ಮೆಂಟ್. ದಟ್ ಈಸ್ ದ ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಅಪೋಸಿಟ್ ಟು ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್. ನೀವು ಯಾವ ಡೈರೆಕ್ಷನ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕೊಡ್ತೀರಿ ಅದರ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಏನಾಗ್ತೈತಿ ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ ಡೆವಲಪ್ ಆಗ್ತದೆ. ಅದಕ್ಕೆ ಏನಾಗ್ತೈತಿ ಸ್ಟ್ರೆಚ್ ಮಾಡಿ ಮತ್ತೆ ಅದಕ್ಕೆ ಕಾಂಪ್ರೆಸ್ ಆಯ್ತಿದೆ ಬಿಕಾಸ್ ದಟ್ ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ ಈಸ್ ಡೆವಲಪ್. ನಾ ಈ ಡೈರೆಕ್ಷನ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕೊಟ್ಟು ಬಟ್ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಏನಾಯಿತು ಅಲ್ಲೇನಾಯ್ತು ರೀ ಸ್ಪ್ರಿಂಗ್ ಮತ್ತೆ ಏನಾಯಿತು ಕಾಂಪ್ರೆಸ್ ಆಯಿತು. ಬಿಕಾಸ್ ಆಫ್ ವಾಟ್ ದ ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ ಈಸ್ ಡೆವಲಪ್ಡ್ ಅಪೋಸಿಟ್ ಟು ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್. ಸೊ ಎಫ್ ಈಸ್ ಈಕ್ವಲ್ ಟು -x ಅಂತ ಹೇಳಿ. So this negative sign indicates what here? Negative sign ಏನು indicate ಮಾಡ್ತೈತ್ರಿ that spring force is developed opposite to the direction of displacement. So F is equal to -k into x. So here k is called as what here? The spring constant, right? Here x is the displacement. Here x is displacement and k is called as the force constant. This k is called as force constant. So we have the one practical based on this. In PU1 syllabus we have the experiment to perform this experiment, spring constant experiment. We have to find the value of spring constant, right? That spring constant k is equal to what? F divided by x. That means what is the SI unit of spring constant, right? The SI unit of spring constant is F is equal to k by x, right? K by x, sorry, k is equal to what here? F divided by x. So F under force field, x under displacement. So Newton per meter. So Newton per meter is the SI unit of what? Spring constant. ಇದನ್ನ ನಾವು ಪ್ರಾಕ್ಟಿಕಲ್ ಮಾಡ್ತೇವೆ, ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಂದ್ರೆ ನಮಗೆ ಒಂದು P1 ಸಿಲೆಬಸ್ ಇದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿ ನಾವು k ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಮಾಡಬೇಕು. You have to find the k value of a given spring, right? So these are the important forces in the forces what we have discussed here about the common forces in mechanics. So one more is about the contact force. So in our syllabus here we have to discuss the contact force. So we have the non-contact forces also. So about in detail we are studying about electricity and magnetism. So in electricity also we have to electricity branch also we have to study, and magnetism also we have to study PU2 syllabus. So PU2 syllabus ಒಳಗೆ ನಮಗೆ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಸ್ಟಡಿ ಮಾಡೋದಾದ್ರೆ, ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಸ್ಟಡಿ ಮಾಡೋದಾದ್ರೆ ಅಲ್ಲಿ ನಮಗೆ ನಾನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸಸ್ ಬರ್ತಾವೆ, ರೈಟ್. So in here we are discussing in this laws of motion chapter about the contact force. One more type of force in mechanics is about the contact force, right. So what is meant by contact force here? The example is we are discussing about the friction. Garshani anta kariteve ನಾವು, what we call it as Garshani anta kariteve. So in detail we have to study about the friction, right. So friction is defined as what? It is the contact force, right. It is what? It is nothing but, friction is nothing but what here? It is the contact force, and which opposes the motion of one body on the surface of another body. ಏನಂತಂದ್ರೆ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಇದೆ, ರೈಟ್. ಈ ಆಬ್ಜೆಕ್ಟ್ ಒಂದು ಸರ್ಫೇಸ್ ಮೇಲೆ ಮೂವ್ ಆಗ್ತದೆ, ರೈಟ್. ಬಟ್ ವಿಚ್ ಅಪೋಸಸ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದಿಸ್ ಇಸ್ ದಿ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್, ದ ಬಾಡಿ ಇಸ್ ಮೂವಿಂಗ್, ಆ್ಯಂಡ್ ಈ ಒಂದು ಸರ್ಫೇಸ್ ಮೇಲೆ ಈ ಬಾಡಿ ಮೂವ್ ಆಗತ್ತೆ, ಅವಾಗ ಏನು ಮಾಡ್ತೈತಿ? ದಟ್ ಮೂವ್ಮೆಂಟ್ ಈಸ್ ಅಪೋಸ್ ಬೈ ಸಮ್ ಅದರ್ ಫೋರ್ಸ್. ದಟ್ ಫೋರ್ಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್ ಹಿಯರ್? The friction is there. That friction is opposite to the direction of force, as we have the applied force, right. It is defined as what? Which opposes the motion of one body on the surface of another body, right. This is called as what here? The friction. Frictional force andre the force, it is the contact force which opposes the motion of one body on the surface of another body. That is called as the contact force. That is in particular in this section we are defining about the frictional force.